Okay, now let's talk about how we're going to solve these. So we want to solve for y. This is saying 5, if we use the definition of logarithms, 5 to the what power, or actually to the y power, equals 1. So what would y equal here? Y equals 0. Okay? Because only thing that's going to give you 1 is the 0 power. Okay, we want to solve for x. I think the easiest way to do this is to use the definition of logs and rewrite it in exponential form. So what's the base? And what's the exponent? -3. And that's going to give you x. 3 to the -3 power. So what is 3 to the -3 power? 1/27. Does everybody see where we got 1/27? And by the way, you could check this on your calculator if you want. So the check, if I plug it in, I could use my log base. So let me quit that. If you have your math log base, scroll all the way down to A, and you could check putting in the base 3. Well, actually, I realize it's not going to check out because, oh no, it will, because I can put in 1/27. 1 divided by 27. That was the answer I got. So when I push enter, it should give me -3. Look at that. So I checked on the calculator. And if you didn't have a log base on your calculator, you could go log of 1/27 divided by log of 3, and you would get the same answer. So you might check that on the calculator. Okay, here we're missing the base. So I have base to what power? 2, right? Here's my power, equals what? 4/9. Can you think about what fraction you would have squared, or how could you actually solve for b? You know how to find the opposite of a square. Square root. So I could take the square root of both sides. The base is going to be what? 2/3. I think we said that the bases should always be positive. So we're not going to use plus or minus. So we would exclude -2/3. Didn't we say someplace that our base should always be? Yes, we did. Right here back in the definition, we said the base should always be greater than 0. So that's why we don't need the negative version. We just need that 2/3. Okay, here, walk me through the steps on how I could solve for x here. Using the definition of logs, what's our base? Start with that. 64. Now, this is either the number or the exponent, but a log is always equal to a log. When I say log, you say exponent. So the exponent is 2/3. Do you guys remember how we dealt with that exponent that was a fraction? Third root of 64 squared. I think that's much easier to take the third root of 64 and then square it, right? Because I don't really want to square 64. 64 times 64 is way too big. Does anybody know what the third root of 64 is? That would be the square root would be 8. The third root of 64 is 4. 4 squared is 16. So if you wanted to check that on your calculator, you could plug that 16 back in and you should get 2/3, or you could say log of 16 divided by log of the base 64, because those are, a lot of you don't have this fancy new fangled calculator. So we go log of 16 divided by log of 64. We call that the change of base. And is that the same thing as 2/3? Yeah, 0.6 repeating. Some of you have math frac, and you can change it back into a fraction, which is 2/3. So that's just me plugging the number in and checking. Okay, this was for a previous problem, that's why. All right, so I've been throwing this around about the common logs. Okay, if you ever just see a log that has no base, it means that it has a base of 10. So if we had log base 10 of 15 equals y, then that would mean 10 to the what power gives you 15, and that would be your y power. Okay, if you see ln, it's really weird because that says ln, but it's actually read natural log. That's like very dyslexic, right? Because ln, natural log, should be nl. But anyway, ln of 15 is log base e. So that would mean e to the y power equals 15. All right.